Hi everyone, thanks for joining us today and welcome to this webinar on how to accelerate Java testing efficiency at scale with AI. My name is Zoe Laycock and I'm responsible for technical product marketing here at Diffblue. And today I'll be co-hosting with my colleague Animesh Mishra.
Hello, my name is Animesh. I'm a solutions engineer at Diffblue. I come from a software engineering background and have lived through most of the unit testing issues we will be discussing today. Over the next few minutes, we'll show you how Diffblue maintains test quality at scale and leaves your developers a little more happier.
So very quickly, we're just going to run through a couple of housekeeping bits just to get started. The session is being recorded. Need to let you know that. We are also streaming live on YouTube. And what we plan to do is actually make some time for Q&A, questions and answers, your questions at the end of the technical demo. So feel free to line them up and use the Zoom platform to actually write them so we can see them, and we'll loop back and try and answer your questions as soon as we can. So let's get started. Unit testing is the foundational form of testing and validating code as we build. And it's a necessity really for achieving really high and good levels of code quality and reliable code. But there's only one problem with that. It can also be a significant roadblock to achieving fast release cycles. It's kind of a perfect storm. Code bases continue to grow in size and complexity. Manual methods of testing, including workflows such as test-driven development, are actually really slow and resource heavy. And a lack of unit testing can hold back the adoption of the most efficient DevOps practices. And so, how can we actually accelerate the testing process and actually make it more efficient, but also easier for developers? Before we dive into that, I just want to take a look at some learnings and insights that we've gained at Diffblue from our customers about common engineering challenges. At Diffblue, our customers include top engineering organizations from the likes of Citi, JP Morgan, Wells Fargo, Cisco, and AstraZeneca, to just name but a few. And we're lucky to be able to learn from these leading enterprise engineering organizations and how they've been challenged, some of the challenges that they've encountered that has actually led them to look for solutions in Diffblue cover. So what have our customers actually told us can be challenging? First off, actually ensuring and maintaining code quality is a challenge in itself. And for some of our customers, they may have been challenged by having unacceptable number of outages in production, or defects that have brought down systems in production, which detrimentally compromise customer experience and also brand reputation. That can be very costly. A second common problem is actually aggressive delivery targets. As everything speeds up, this can result in developers not actually having the time to write high quality unit tests, and therefore actually having to choose between comprehensive testing or timely delivery, and that's not ideal. Thirdly, another problem, particularly in the Java space, is actually being slowed down by technical debt and the need to actually migrate legacy applications to modern cloud or hybrid cloud architectures to be able to get the benefits of hosting an application in the cloud. And a barrier to success here can be the understandability and knowledge of those existing legacy code bases and the lack of unit tests. A lot of the time, they've been written by developers that are long gone. And finally, new customers are increasingly telling us about the mandatory code coverage targets that are being introduced as a quality measure. Now, this can be good, but it actually poses real challenges in terms of how to actually rapidly achieve and maintain those coverage gates. And against the backdrop of all of these challenges, there's also a demand for rapid innovation and continuous improvement of customer experience. And this necessitates a more agile approach to both software development, but crucially, the testing of the application code. So what are our current options for continuously testing? Well, we've got traditional manual unit testing. We're all familiar with that. But we're also familiar with the fact that it can be time consuming, labor intensive, especially for large and complex code bases. Testers need to execute numerous test cases for each unit of code, which can be extremely tedious and inefficient. And then manual testing is actually prone to a lot of human error. It's repetitive, it's mind numbing. And it's highly susceptible to human mistakes, such as missing edge cases and failing to actually notice subtle bugs and regressions. And then from a coverage perspective, achieving comprehensive test coverage manually is actually really challenging. And it's especially challenging for complex applications. So unfortunately for us, things have actually moved on. And, income, AI and AI coding assistance. But how do these actually stack up? Well, they're better than doing things manually, that's for sure. But there are some limitations with AI coding assistants. And I think at the beginning of this year, everyone is excited about using them. And the plethora of coding assistants that there are. And towards the end of the year now, as we reflect on what are those productivity gains, people are actually starting to become more skeptical about AI assistants, and particularly about the quality of the outcome of their output of their code. They're not context aware, and they make suggestions that still require manual and developer input. And while they're useful for generalist coding suggestions, they actually lack the understanding of project context, architecture, and also the business logic. They can also miss important edge cases, and they can fail to test complex interactions between components and dependencies. And as the code base evolves, LLM generated tests can actually become outdated or even irrelevant in the absence of automatic updates as the code changes are actually made. The founders of Diffblue knew that there had to be a better way to actually make continuous testing and code validation easier and viable for developers and development teams. And with that, Diffblue Cover was born. Diffblue Cover is an AI-powered unit test automation solution for Java developers and teams that writes and maintains unit tests so that you, the developer, don't have to. It's an AI native solution, and it's different. It's different from other AI code creation tools in many ways. One way is that Diffblue covers an AI agent. It's actually not a coding assistant, and it's 100% autonomous. What do I mean by that? Well, Diffblue covers ML trained exclusively on your code base and comprehensively writes unit tests, all of the unit tests that are needed, that are 100% ready to go. Those tests actually compile, they pass, they reflect the behavior of your code, just as if an experienced developer that was totally familiar with the code base had written the tests themselves. So you can run Diffblue Cover against your entire application, or you can get fast feedback within a loop testing and just test methods and classes as you go. It will generate a suite of unit tests that are ready to go and require no human intervention to actually thoroughly test. And the second difference is that Diffblue cover can actually run locally on your laptop. When writing the most critical unit tests, developers can do that as they code, and Diffblue cover will actually generate the test for them. And additionally, it runs automatically in CI, where the majority of the bulk testing can actually take place. What we would call at Diffblue vital but tedious testing. And this can be completely automated. When running CI in CI, Diffblue cover gives every single developer in a team the consistency of coverage and the best test protecting every code change, every commit, and every PR from regressions. And then there's a third scenario. Sometimes manually generated code is just not testable. And where that's the case, you need to know why. So Diffblue cover also provides advanced, helpful feedback and insights about code testability and testability, which can help you, the developer, focus on targeted, low-risk refactorings that make the code testable. And finally, Diffblue is an AI that you can actually trust. You can hand off your unit test writing to Diffblue cover. Its test code is actually more accurate and comprehensive and context aware than an AI assistant test output. And Diffblue cover is actually an on-prem solution. It remains 100% in your business environment. There's no cloud. And therefore, at all times, you, the organization, have complete ownership and control of your code. So, in a nutshell, that's Diffblue cover. And now I'm going to hand over to Animesh to show you how to accelerate Java testing efficiency at scale.
Thanks, Zoe. Before we get to the live demo, which we will get to in a minute, I promise, I just want to show you what we will be doing. So we'll start off by using the command line interface to write test at bulk at our mainline branch. This would typically be the branch that you deploy to your customers. Idea being that the day you adopt cover, you use Diffblue to capture the behavior of the application as it is deployed to your customers by writing some baseline tests. From that point on, you've got a regression test suite helping you protect every code change you make from there on. When you do make some code changes in open pull request, Diffblue CI integration will kick into gear. It will run the change you've made. It will run the unit test an existing unit test, and will make sure that the test suite is adapted to the code change you've submitted, so that you can be confident that the change that you've made accurately captures the functional requirement. If it doesn't, the engineer will need to go back to their code and fix the pull request until such a point where the code that you're seeing and the resultant behavior demonstrated by Diffblue test match the functional requirement. If all looks great, you can merge the code and move on. I'll start sharing my screen here now. Thank you. On my screen, I have a terminal where we will use the Diffblue command line interface to write test at bulk. This command here, dcover create, will ask Diffblue to go and analyze our demo application and write tests for every single class and method in here. It's an autonomous tool, as Zoe's mentioned. It doesn't require any babysitting, no prompt engineering needed. It will nicely sit in the background, spin away, and create an entire unit test suite for us within a few minutes. While it does that, let's have a look at how the application works, the code and the test, and then we'll see what Diffblue has code for us. Our demo application is a sample application developed by the Spring Framework team. They call it Pet Clinic. It's your typical model view controller style application. We're going to look at this find pet owners form, which allows one to look up pet owners by their last name.
Hi, Ramesh. Sorry, we can't see your screen. You may need to try and share it again.
Okay, thank you. Better now?
Yeah, we can see it now.
Okay, cool.
Sorry
So
about that, everyone.
no worries, sorry about that. So when I started talking, I ran this discover create command to kick off test creation for the whole class to begin with. Diffblue will go run in the background and write the test for us. Meanwhile, we'll look at the application. So this is the Spring Pet Clinic application that we're testing today. And I'm looking at the Find Pet Owners form. This form here has a few distinct behaviors. If you don't specify any search phrase and click Find Owner, it takes you, it returns the whole database in a paginated fashion. If you look up a name such as mine, it tells you if it doesn't exist in the database, you get shown a helpful not found message. If you are looking for a person and there are multiple pet owners in the database that share that last name, you'll get shown a paginated list of all the Davises. Then you can click through and get to the right one's contact detail. And finally, there's a neat little optimization. If you look at the person and there's only one search entry in the database, we skip the pagination business and get taken straight to their profile page. So 4 distinct behaviors. If I were writing tests for this form as a developer, I'd make sure each of these were covered so that even the smallest of changes in the future will get caught by one or more failing tests. The code that powers this search form is a process find form Spring controller method. We can see it has a few different code parts in here. This was the empty string that returns the whole database in a paginated fashion, followed by our not found case. Then we have our nice optimization. When there's a single item in our search result, we get redirected straight to that profile. And lastly, the pagination module, so that when there are multiple items in our search result, we get shown a paginated list and we can find the one we're after. We've asked Diffblue to go and write tests for the whole application, so it will step through each and every class and write tests as it goes. But while it's doing that, let me walk you through how Diffblue writes tests. We do not use any large language model internally. We use a completely different machine learning technique called reinforcement learning. We analyze your built bytecode, not the plain text Java source code, to understand all the classes and methods that make up your application. Off the back of this bytecode analysis, we not only understand how many methods and classes you have, but also how they're interconnected to deliver the functionality your application delivers. After that, we'll pluck a method out and run it in an isolated sandbox to understand its runtime behavior, all the effects and side effect it causes when it's actually run, and the changes it makes to the application state. We'll use that analysis to then predict an initial test case for that method, and we run that test case against the code running in Sandbox to measure things such as the coverage obtained, how readable the test case itself is, and a few of the secret metrics which help us answer the question, is this a good unit test? If the answer comes out yes, we'll commit that to the code and move on to the next behavior. If the answer comes out no, we'll discard that test case and keep going through this loop 1,000 times a second until a great set of unit tests have been written. And all of this AI analysis, validation, synthesis happens entirely on device, completely offline. So it protects your data and privacy. You don't need to sacrifice your IP and security posture just to be able to use AI. And we're able to do all of this about 250 times faster than a developer and 60 times faster than LLM-based tools like Copilot. We go back to our terminal. We are in the owner controller class, and I can see Diffblue has finished writing tests for that. We can jump straight to our results. So far, as a developer, all I've done is, at the start of this demo, run this one command, discover create, to ask Diffblue to go write tests for my application. Then I've been showing you how the application works. We've been looking at the code. What Diffblue has done in the background has produced a fully valid Java test class for me. Diffblue tests are 100% production ready. What do we mean by that? They will always run. They'll always exercise the method under test, and the assertions they have always reflect the true application runtime behavior. We can validate the first two claims, that they run and exercise the code under test, by running this test class with coverage. If the code compiles and runs, we should see all the tests passing. And then if they're actually exercising code under test, we should see some meaningful coverage number as well. So all the tests do pass, that's great to see. And we've managed to get 95% coverage out of the box. Not bad for a few seconds work. But what sets a unit test truly apart is its ability to catch regressions. And that is keenly tied to the assertions it writes and how well it's capturing the application behavior. We're testing the test process fine form, and we can see it's written, Diffblue has written a few different test cases for this method. The first test case covers a scenario where we're not providing any search input. So that's the empty string that does the broadest possible search. The next test case covers the single item doing a redirection scenario. Then we have multiple items showing a pagination list. And finally, we have the case where we are looking up a name that doesn't exist in the database, the not found case. I'll focus on the middle two because they're the more nuanced, meaty cases. This scenario, this test case covers the behavior when there's a single item in a search result and we saw a redirection happen. All unit tests that Diffblue write will always follow this standard arrange, act, and assert pattern as you and I, as developers, do when writing unit tests. Up top here, Diffblue has created some test data. The solution ships with the limited dictionary, where it can create meaningful test data for commonly occurring entities such as name, city, address, phone numbers, etc. For more domain-specific tests data, we have a custom inputs feature, which allows you to supply that so you're not stuck with what Diffblue can produce out of the box. Once you've initialized the application content, so it's created some test data, initialize the application content. Let's not break the test live. Okay, and then it's using the mock MVC framework to drive the search and asserting on the redirection behavior that we saw ourselves. So not only do the test run and exercise the code in the test, the assertions in them reflect the true behavior of the code as we can observe as well. If we continue to the next case, again, some more test data being created. This is a scenario when there are multiple items in the search result, and we see a paginated list with all the result items. Diffblue has created two distinct instances, so it's smart enough to know that this list needs multiple different users. It's not just creating copies of Jane Doe's. Initialize the application again, using the mock framework to drive search, but this time asserting on seeing a pagination list instead, because that's exactly how the application works. So far so good. This is a tool that can create test classes for us out of the box without any developer intervention, and those tests will run and they will test the application behavior properly. I want to do one last thing, and that is I want to try to break this application. So what I will do is I am now going to get rid of the redirection behavior that we have in the application. So from this point on, before this, if there were a single item in our search result, we would see us getting redirected to that profile page. The change I've made, that would just show a paginated list with one entry with that particular search result. At this point, as a developer, every time I go into an application, make any code changes, my first instinct is to go back to the test class and run all the tests to see and make sure that I've not introduced any side effects. Now, because I have made change to the code, I'm expecting some test cases to fail. I'm expecting exactly one test case to fail, which deals with that optimization scenario. But if anything else starts failing, that would alert me to the fact that maybe the change that I've made wasn't as localized as I thought, wasn't as clever as I thought. So I'll run this again. Don't need coverage this time. And lo and behold, most of the tests do pass, which is great, which means my code change is indeed quite localized. One test case does fail though, which is the case that deals with my optimization redirection scenario. Single result, expecting to see a redirection. We've just changed the code to do a pagination. Obviously, it fails. Now I have to update this test case. to capture new behavior. I could always go back to the command line and do it using the command line, but we do have an IDE plugin for IntelliJ IDE, which makes this process much faster and with a neater developer experience. You can download the IntelliJ plugin by going to the IntelliJ plugin store and searching for Diffblue cover. It should show up in the list, and it works just as fine for both paid and free versions of IntelliJ. So you don't need to pay IntelliJ to be able to use Diffblue cover. Once you've installed the plugin, you get a nice little flask icon in the left-hand side gutter next to line numbers. It's got a plus when you have a Java source file open, which indicates you can click that to write a test. When you have a test file open, that plus changes to a wrench, which you can click to either remove the test if that particular functionality is no longer relevant for your application, or update the test to take into account the new behavior you may have introduced. The first option is what I want, so I'll click that button and we'll see how Diffblue processes the code change that I made and updates the test case for it. Both the command line and the plugin and the CI integration, which I'll show you in a minute, they all use the same AI engine. They'll always get, and Diffblue is a deterministic tool. So given the same version of Diffblue, and the same version of code, you will always get the same test output, regardless of which flavor of Diffblue you use between the IDE plugin, the CLI, and the CI. So this determinism is a key part of our design process. We make sure that Diffblue output doesn't change from one day to the other, because it will be an absolute nightmare that every time you open a pull request, your tests come out differently because we have a probabilistic model sitting in there. So I can see here Diffblue has finished writing test. I'll quickly show you talked about this environment checks too. Before you point Diffblue at an application, when you point Diffblue at an application to write test, before even starting its analysis, it does what we call pre-flight checks, which are environment checks. We do so because we want to make sure, and Diffblue wants to make sure, that the project you've given it is something it can write tests for. So the sort of things it's looking at are the build system being used for the project. We support Maven and Gradle out of the box, and other build systems such as Ant are supported too. They just need some configuration. Then it looks at the JDK version. We support long-term support versions for JDK 8, 11, 17, and 21. And then finally, it queries your pom.xml if you're using Maven, or build.gradle file if you're using Gradle, to understand all the testing, mocking, and application frameworks that make part of your application. We do this analysis because when we write our tests, we're going to use the libraries that you have specified. Diffblue does not ship with its own version of JUnit or Mockito or Hamcrest or other things. If you have these specified in your project, Diffblue will use them and the exact versions listed. If there are any incompatibilities between the versions which are listed in there, the test might not come out as good as they should, which is why we do these pre-flight checks. In this case here, we have a green tick throughout, which means not only are all of these libraries something Diffblue supports, but the versions that you're using also matches the best known configuration that the package authors recommend for these libraries. At that point, it has no issues. It will move on to write and update tests as requested, which is precisely what it did here. So it ran, it looked at my code change, and has come back to my test class and updated the failing test with the single result scenario to now do an assertion on seeing a paginated list as well, which is exactly how my code works. So I can run this. My test passes now because it matches how my code works. And at this point, I can open a pull request and be fully confident that I've tested my code inside out, and there's no side effect that's been introduced. What I want to show you now, finally, is the CI integration, which is where I've made the same changes, except one thing: I did not create the test locally. So this is a pull request I created not too long ago, where I made the same change, swapping out redirection with pagination, but I've not committed any test, as you can see in this diff. What I want to show you is even if you forget to run Diffblue locally, or even if you don't run Diffblue at the right scope and miss out some of the tests that should have been updated, as long as you have the CI integration enabled, all of those will be caught before your code review process, so that when you get to code review, you have a complete understanding of how the code change that you have submitted affects the application behavior. So in this case, I've just made my code change like a vagabond developer, push the commit, and then open the pull request. As soon as I do that, in this GitHub repository, I have the GitHub Actions integration enabled. We have one-click integration for GitHub, GitLab, and GitLab, but what I'm showing you works just as fine on on-prem Jenkins or any other CI platform you may be using. It's basically the command line that we run locally. We configure that for CI, and it works everywhere. You can run a command line with just all CI tools. So when I open my pull request, Diffblue does exactly what I did locally. It runs the existing test suite. Some of the tests do fail, which is what we saw as well. One test failed. As soon as the test fails, that's a signal to Diffblue that application behavior has changed. I must do some work. I must make sure that the test suite now matches whatever the new change is included in this PR. So it will first push a commit, which is this one, where it removes failing test, and then it will push a subsequent commit with the new test cases it has written to match the code change submitted. So as a code reviewer and developer, you see two things. You see the code change that you have submitted, which is there, and the resultant change in the behavior of the application as evidenced by the assertions. So we can see what was a redirection before is now a pagination. This is precisely what my functional requirement was as well. So I've swapped out redirection with pagination, all of my other checks pass, and the code is written in the style that I want to. Check, check, check. I can merge this code knowing fully well I'm not going to wreck production on a Friday night. Coming back to where we started, we asked Diffblue to go write tests for the whole application. It's gone ahead and written 80 tests for this app. A single unit test takes about 15 minutes for a developer. So 80 tests would take you a week worth of full-time developer effort. Diffblue has done that in less than 6 minutes. And each of these tests, 80 tests, are just as valid, just as complete, just as regression busting as the ones I've showed you. And that's Diffblue cover in a nutshell. It writes unit test suites for your Java code bases completely autonomously. It works in the IDE through the IDE plugin. It works locally and write tests as bulk using the command line interface. And it protects your every single code change from regressions by sitting in your CI and looking at every pull request submitted on a project. Once you've written all of these 80 tests, though, and once you're covering all of your applications, you might have a natural question. What does my coverage look like? How is it distributed across the application? How much is Diffblue contributing to that? And if I have an application which has poor coverage, how can I improve that? To answer all of these questions, we have the final piece to the Diffblue puzzle, which is cover reports. Cover reports is an application that's included with your Diffblue cover license, and it's a coverage analytics application which shows you coverage you're getting not just from manual test, but also from Diffblue test. What's the overlap, and what value you're driving from cover. I'm going to take example of the Spec Clinic project that we're looking at here. So let's make this test bigger. It's probably not that readable. So the top line figure, it reports the total coverage on an application, but then we break it down further in this graphic, which is quite helpful. Okay, maybe we don't want it this huge. Much better. And we break it down in this graphic, so you can see coverage you're getting from Diffblue test alone. You also see coverage you're getting from manual test alone, and then you see the overlap. Now, in this project, because it was fully covered before we pointed Diffblue at it, there wasn't much room for Diffblue. I'll show you a couple of examples where this number is different. The idea being that the reason we break down this overlap is so you can see how much of your code is being covered twice, once by Diffblue test and once by manual test. And if you're happy with the quality of Diffblue test coming out, you can decide not to have to maintain this 91% of code unit test that you're actually maintaining today. So if this number is quite high, that tells you that there's a lot of maintenance time savings to be had if you offload the work to Diffblue. If this number is very high, that's just complete net new coverage. This is usually high when you use Diffblue in an application without much coverage. And so then you get 60, 70, 80% out of the box, and then that looks that big. Once you've seen the application headline figures, you can go to the View tab and see how that application is distributed across different packages in this application. Let's keep digging. Here you can see it's got a few different packages. Most of them are quite well covered, actually. I will go to this web package, and I can see there's this our owner controller class. This is the class we were looking at locally, and we can see most of the methods are quite well covered, including our process find form, but there are a couple which aren't so. We can now move to the coverage detail tab, where you see the last bit of Diffblue advisories. So where Diffblue isn't, when we ask Diffblue to go write a unit test for our code, it goes and tries to write test cases for all of the code in your method. It may or may not always succeed. In cases where it doesn't succeed, because it has a computational understanding of what it's doing, it will be able to leave behind what we call advisories or output codes. These would be comments to developer explaining that why did Diffblue either not write a test, or what happened when it tried to write a test but couldn't. So here, when you come to the coverage detail tab, you can see these different advisories for across your different classes and methods in the application. So here we have in the owner controller class, there's a trivial constructor. So typically we don't write tests for trivial constructor because they just create noise. The way we define a trivial constructor is a constructor that takes in some values, assigns them to a property, and there's not much logic in there. So there's no point testing the Java assignment operator. So we don't write tests for trivial constructor. Similarly, we don't write tests for framework configuration callback methods. So these would be methods that you need to pass on to a configuration to set it up. So some settings or some environment variables. There's no point testing those out because, again, those are simple assignments. So we don't write tests for that. These output codes sometimes can be messages like these where they tell you why Diffblue didn't write tests. And sometimes it can be cases where Diffblue did try to write a test, but couldn't. In those cases, you can click through on that and it will take you to our website, documentation website, where we explain the output codes in detail. And there's a detailed documentation on what to do when you see certain common output codes. One of them is something we see every now and then, which is R013. This happens when Diffblue tries a variety of test inputs for a particular piece of code, but it can't seem to find any that doesn't throw an exception somewhere in the chain. In that case, after trying out for thousands of iterations, Diffblue eventually gives up and says, look, I can't seem to find the right kind of test input. Please, can you help me? So we'll leave this kind of code. If you see that in your project, you'll be brought to this page, which describes how you can find the root cause, how to help Diffblue understand what kind of test input to use. And then once you've made these changes, you run cover again, it will be able to write unit tests for that piece of code, and then you get additional coverage. So you use Diffblue cover to understand where you're lacking your coverage, the reason for that, and what actions you could take so that when you run Diffblue again, it can come in and mop up the rest of the work. So all in all, that's Diffblue cover in a nutshell. We have many large customers using Diffblue for stopping outages in production. Cisco at the moment has rolled this out on their 6 million lines of code, which is protecting their 200 million IoT devices globally. Goldman Sachs saved a year worth of developer effort when they were modernizing a legacy app internally by using Diffblue to write tests at scale using the command line I showed you. And we have many customers who are working on projects where they're either moving to the cloud or they're already in the cloud and they're launching new products which have come with a deadline, and they use Diffblue to reduce their time, shorten their time to market by offloading the time the developer would be spending writing tests to Diffblue so they can focus on delivering the features that bring home the bacon. I will pass now back to Zoe, but you can try Diffblue too. Go on this, if you can scan this QR code, it will take you to our Teams trial. You get 14 days to play around with it. You get access to both the command line interface and the IntelliJ IDE plugin. The IDE plugin is available for IntelliJ only at the moment. So if you don't use IntelliJ or you're not allowed, you can try the command line interface, which works both on Windows, Macs, and Linux as well. So give it a go, write some tests. Here's my email on slide as well. I would love to hear your feedback, both good and bad. Bad is even better because that helps me helps us improve the tool even further. The next time I do it, I have something cooler to show you. Thank you very much.
So we hope that we've given you a walk around Diffblue cover and what you can achieve with it. As Animesh said, the best thing is to try it on your own code. We've actually walked you through many of the capabilities of Diffblue cover Teams edition today, which basically covers inner and outer loop test capabilities. But actually, if you're interested in just getting your hands on Diffblue cover to actually try it, you can also, from our website, diffblue.com, you can also download the community edition that will give you just those inner loop capabilities in IntelliJ. And you can play around with it, and it's free forever. So please do go and try it out. So thank you. Really appreciate you joining us today and for your interest in Diffblue. Weirdly enough, we actually don't have any questions. So I'm just going to very quickly remind you, if you have any questions for us, please drop them in the Zoom Q&A. We'll just pause for a while just to see if anyone does have any questions. But Animesh, I'm going to pop a frequently asked question to you that we get asked just to kick things off. So Diffblue cover, what happens if I use Eclipse and not IntelliJ? Does Diffblue cover work with Eclipse?
The IntelliJ IDE plugin, the IDE plugin is only available for IntelliJ. If you use Eclipse or any other IDE, the best course of action would be to use the command line interface locally to write your test, and use the CI integration to scale it across your teams.
That's great. All righty. And in terms of CI, we've talked about CI a lot.
But actually, I'll add one more thing in there.
Sure.
What you could also do is, if you really wanted, there's a Maven plugin, which you can just put it in your Maven configuration, so you don't even need to worry about using IDs. It will look at the diff patch you have and write the test every time you run Maven build or Maven test.
That's great. In the meantime, we've actually got a question from Marius Lungu. Thank you for joining us, Marius. And the question is, can Diffblue, and I'll just correct you there, it's Diffblue, but can Diffblue as well generate integration tests? If not, is there any plan to? Good question.
That's a great question indeed. Yeah, we currently write unit tests only for Java and Kotlin. I would leave. There are integration and functional tests. They are not on the roadmap on the immediate release. I will leave to Zoe if there are future plans, but I can guarantee for the next year or so, we do not plan to write expand into integration or functional test territory.
Thanks so much. And we have another question, possibly an alias or possibly a name, not sure. Inner, does the code coverage percentage increase? Is it better if we use the paid version of Diffblue, or is it the same as the free version? Great question.
Yes, the short answer is yes, but not because we are using a different model or different capability if between paid and free versions. The reason coverage will differ if you use a paid version is because in paid versions we don't have any limits on the number of tests you can write. So if you start from the Enterprise Edition, there's no limit on the number of tests you can write. We bill you based on your lines of code usage. If you come a level down from there, if you use Teams Edition, you get fewer lines of code, but there's no limit on how many tests we'll write for that particular application. Then when you get to the free model, we do limit the number of tests Diffblue produces. So even though it's the same model that's writing the same kind of test, because the number of tests are limited in free version, naturally you will not get the most coverage that you could get if you were paying for it. But the free version is a very good way to test out, and the free trial as well, if you scan this code, to see if Diffblue can write quality tests for you, because the kind of tests you will get for the free version are exactly what you'll get for the paid version. There's no change in the quality of the test coming out. It's only the number that changes.
Fantastic. Inna, I hope that answers your question. Keep them coming if you have any. In the meantime, we'll just quickly dive into CI pipelines and which ones we support. Can you just tell us which CI pipelines are supported with deep integrations by Diffblue Cover?
So there's two levels of integration to be had here. One is a completely hands-off, one-click drag and drop integration, which we have for GitHub Actions and GitLab. This works both for self-hosted GitHub and GitLab, and also if you're using just github.com or gitlab.com. These one-click integration just do all the work for you. So what you get, let me actually show it to you. GitHub Actions Diffblue. What you get is a sorry, just a sec. There you go. Diffblue Cover pipeline. So you get this ready-made GitHub Actions for GitHub. Similarly, on GitLab Duo platform, you have Diffblue options which you can just immediately enable for your projects. If you're using that, all you need to do is literally just click a few buttons and it's all configured for you. That's the hands-on one-click integration. Takes about 20 minutes to set up. Then we look at the more hands-on integration that works for every single CI platform out there. That takes about 2 or 3 hours to set up, because what we need to do is just write a simple script that downloads Diffblue within your CI container, activates the license, and then calls the create command just like I did locally in the CLI. That's all it needs to do. 3 steps, commit the changes back to your project, and off you go. So depending on which versions of CI you're using, it could be either 15 minutes or 3 hours, but it's a one-off thing. You set it up and then it will work in the background all day long.
And I think that's a key point, actually, because when we're talking about bulk creation of unit test suites at scale, this is the part of the capability that we are talking about, to generate unit tests comprehensively so that you don't have to write them yourselves. I'm going to move on to Mustafa. We have a question from Mustafa. Welcome. Thank you for joining us. Your question is, how does Diffblue work behind the scenes? I see in logs it's trying to connect to a server. Though it's an offline, I think this means it's an offline process. Do you generate tests into your remote server or offline?
Offline. So good spot, by the way. And it's an implementation detail, so this might change by the time I next talk to you. But the way it currently works is there is a server. That server is not somewhere else. When you run the Diffblue create command, we will spin up a couple of VMs locally. One of them is called the analysis service, which runs at a local TCP port. The test writing service tries to make connection to this local TCP server. Sometime, because of local system configurations, corporate security settings, this breaks down, and that you might have seen an error around this in the logs, or you might have just seen the normal operation logs. But that's what's happening. Diffblue supports a completely offline mode in the enterprise license, where there's no connection to internet required whatsoever. In fact, the demo that I did using my command line is actually using offline licensing mode. So that's the short answer. If you've seen in the logs some references to talking to a server or listening to some event, that's all the local services we're spinning up as part of our analysis and test writing services. There's no communication happening outside your network for test writing purposes. If you use the trial or the, so for Teams edition or trials or community edition, there are two network calls that we do make. One is to check that your license is valid, and second, to send any error reporting, but we're not sending any code in those cases either. A good spot.
I hope that answers the question. Moving on to Marius. Marius had a question. Knowing Kotlin, that means that we can write unit tests for Android as well, question mark.
I'm afraid not. So, and the reason for that is we don't support the Android framework at the moment. When I say we don't support a framework, typically what we mean by that is there is an idiomatic way for testing framework code. So Spring Boot, for example, ships with its own library, Spring Boot test, which shows you how to idiomatically natively test Spring Boot tests. Similarly, if you're using Android, there's a specific idiomatic way of writing UI tests. At the moment, we don't support the Android framework. So if you have Kotlin code that is just doing some backend stuff or just some Kotlin stuff, we can write tests for that. The moment it gets into the Android territory, if it's using the Android SDK, we won't be able to mock it well, which means you won't get as high quality tests.
Superb. All right. And then Nilanjan Islam, thank you for joining us. Your comment is, I've missed the beginning of the demo, so not seeing how Diffblue needs to be connected with the source code before it writes unit tests. Are we going to get the recording off of the session? Absolutely. So every time you register for a Diffblue webinar, we make sure that you can either join us live, but we also make sure all live attendants and in fact all registrants will receive a copy of the replay, which will be hosted on YouTube. So the answer to that is the full demo, the full presentation, full webinar will be available to you very soon. We usually have a turnaround of approximately 48 hours. It will be with you early next week. So I hope you get to see the whole webinar. We certainly know that not everyone can make it at different time zones when we get started. So please feel free to come back to us. You can see on the screen Animesh's email address. And we also have a community forum. So if you have any questions further for us, either about testing Diffblue yourselves or just any curiosity questions, please drop them to us and we'll be happy to answer them. So Pascal had a question. Sorry, go ahead.
Yeah, thanks, Nilanjan, for that question. Actually, you're not the only one who missed the start. So did I. I actually wasn't sharing the screen when I was showing. So that's a very timely question. I'll show you what I did for everyone's benefit. We started off by looking at the application. The first thing that you need to do is you need to make sure that the application has been built. So your Maven clean install, if you're using Maven. That is so because Diffblue looks at the build bytecode of the application, not plain text Java source code. Once the application is built, all you need to do is at the root of your project, so this is where your parent POM file is, run a command dcover create. Diffblue will then go and discover everything by looking at your POM, identify your project structure, where the code resides, and will all the application frameworks and libraries that make it up. It will go discover all of that, the Java version, and then start writing tests. So the only thing you need to do is make sure you have built your application, then go to the root of the project, run dcover create, boom, you can have a test suite in about 5.5 minutes.
Thanks very much. And then we have a question from Pascal. What are the limitations in terms of project sizes, lines of codes of Diffblue? Can it generate tests for a very complex application?
We have generated tests for very complex applications. It's really dark, actually. Let there be light. We have generated tests for many complex applications. So I would like to understand what you mean by complex. Is it more in terms of business operations or just the way it's written? But yeah, we have enterprise customers who have used Diffblue on projects of varying size. The largest I've seen is an 8 million lines of code we had with one of our banking customers. Diffblue took about 8 hours, 8.5 hours to write test case for the initial baseline test for the whole application. And from that point on, it's only a few seconds as you make little code changes. There is no token limit or window limit or the kind of those limits that you see in LLMs, because we're not using an LLM. It's a completely different machine learning technique. We're looking at your bytecode in a piecemeal fashion, run a method at a time, write all the tests for it. So there's nothing in terms of lines of code. There's no limit like that. And the complexity, we are able to handle most of the enterprise application that's been thrown at us. Yeah.
Great answer, and thank you for the question, Pascal. I mean, there are two ways to look at this. Obviously, we have a Teams and Enterprise edition, which is meant for exactly that, teams and enterprises. But you also have the Community edition, which you can use as an individual developer. And that's limited to, as are most free forever versions, to writing 50 tests per month. You will actually see, in terms of coming from us very soon, some changes to these limits that in general will benefit everybody by increasing their limits and how we actually measure those limits. But you have different options about how you can use Diffblue Cover today. And so with that, we conclude the questions. We are almost at the top of the hour. I'd like to really thank everyone for joining us and for your interest in Diffblue Cover. Please do try it out, try the trial or the community edition. And that's a wrap, essentially. I'd like to say a big thank you for joining us from me, Animesh, and wishing everybody a good day or a good evening, depending on where you are. Thank you so much, and enjoy the replay, which will be coming early next week. Thank you.